Today we're looking at the diagonals and polygons activity. We're going to be filling in the information from the following table, and we're going to be drawing diagonals from one vertex only. You're going to be choosing a vertex, and then we're going to figure out how many triangles that each polygon can be divided into. The diagonals you draw will not intersect. They're not going to crisscross in the middle. We're going to use the number of triangles we have and the knowledge that we have about triangles, which is that the sum of the interior angles of a triangle equals 180, so that we can calculate the sum of the interior angles for any polygon. So the first thing we want to do is identify the polygon, how many sides it has, how do we go about getting the diagonals. So if I'm looking at the first figure, I have a picture of a triangle. I know it has 3 sides. And I know it's only one triangle, and 1 times 180 gives me 180. So notice I have a process column here to write my equation, and an answer column here to write down my answer. If I look at a quadrilateral, it has 4 sides. If I draw a line from one vertex, I'm going to choose this vertex, and I'm going to go across my quadrilateral. I've broken my quadrilateral into 2 triangles. Because I have 2 triangles, I want to multiply 2 times 180, and that will give me 360. So if I added all the interior angles in that quadrilateral, all 4 angles, it would equal 360 degrees. If I look at the next shape, it's called a pentagon. It has 5 sides. If I choose a vertex, I'm going to choose this top one, and I want to draw the diagonals from that vertex. I can draw a diagonal here, and I can draw a diagonal here. That's cut my pentagon into 1, 2, 3 triangles. So my process column, I'm going to multiply that 3 times the number of degrees in a triangle and come up with that answer. I can't multiply very easily without a calculator. So I want 3 times 180, and that gives me 540 degrees. If I choose a hexagon for my next shape, it's got 6 sides. If I choose one vertex in that hexagon and I want to draw diagonals, I can draw 3 diagonals. I've broken my hexagon into 1, 2, 3, 4 triangles. To figure out the total number of degrees in that hexagon, it'll be 4 times 180. And you can calculate that out. In the same way, you should be able to complete the heptagon, the octagon. We're going to look at a nonagon and a decagon, but we will not need to draw the picture for those. By that time, you should be able to figure out what's going on with the number of sides and how many triangles it will take if you had a picture that you were going to draw diagonals. Go ahead and finish out your heptagon, octagon, nonagon, decagon, and then join me in just a minute or so when we look at what happens for any polygon. I want to go ahead and generalize that last row with you in just a couple of minutes. When we're looking at the number of sides and the number of triangles formed, we want to relate those 2 values. So I'm taking a look at the values that we should have calculated. If I had 3 sides, it formed 1 triangle. 4 sides formed 2 triangles. 5 sides formed 3 triangles. 6 sides formed 4 triangles. 7 sides formed 5 triangles. 8 sides formed 6 triangles. And without drawing it, you should have come up with 9 sides would have given you 7 triangles, and 10 sides would have given you 8 triangles. In every case, the number of triangles is 2 less than the number of sides. So if I'm generalizing for any number n, any polygon, if I have n sides on my polygon, it will make n minus 2 triangles. And if I wanted to find the sum of the interior angles for any polygon, I'm going to take that n minus 2 and I'm going to multiply it times 180. So the formula to find the sum of the interior angles for any polygon is the number of sides minus 2 times 180. Basically the number of triangles I can form times 180. On the back side of the page, we're going to fill in the number of angles for each shape, which is the same as the number of sides, and the sum of the interior angles that you found on this previous page. So go ahead and fill in those 2 columns of this chart, how many angles each shape has, the total that you got from the previous side of the page, and remember that we did generalize for any polygon n, we had n minus 2 times 180. On this page, we're going to be calculating a couple of different things. If we have a regular polygon, we want to find what each interior angle is. Then, with that regular polygon, we want to calculate which each exterior angle is. And knowing how many angles we have, we want to come up with the sum of the exterior angles. Remember, the exterior angle forms a linear pair with the adjacent interior angles. Again, we're going to have some equation columns and some answer columns. So if I have a triangle with 180 degrees for my total, I'm going to take that sum divided by the number of angles. So I'm looking at these 2 columns. I'm going to take 180 divided by 3 to get an answer. That would give me 60. I want 360 divided by 4 to get an answer. I want 540 divided by 5. So notice that my numbers are changing here as I'm working my way around my problem. That's how you're going to find your interior angles. You've got an equation column and an answer column. Finish off those columns for your hexagon, heptagon, octagon, nonagon, and decagon. Notice that what you've done for any polygon, you've taken that total, that n minus 2 times 180, and you've divided it by the number of sides, or divided by n. So when you're generalizing for any polygon, and you want to find the interior angle of a regular polygon, we're saying all the angles are the same, you're taking your total, your n minus 2 times 180, and you're dividing by the number of angles you have. Now that we've found all the interior angles, let's figure out our exterior angles and our sum of our exterior angles. Because my exterior angles form a linear pair with my interior angles, I take 180 minus to get my answer. So for the first one, I want 180 minus 60. 180 minus 60 gives me 120. The second one, I want 180 minus the 90. 180 minus 90 gives me 90. Then I want 180 minus my 108. I'm taking 180 minus the column that's right in front of it. 180 minus 108 gives me 72. Go ahead and fill out that information for your hexagon, heptagon, octagon, nonagon, and decagon. We're not going to fill in an equation yet. We're going to work our way backwards when we get the sum of the exterior angles. Once you've found each exterior angle, we want to find the sum of the exterior angles. So I'm going to take that exterior angle times the number of angles. So I'm going to take my 120 times my 3, my 90 times my 4, my 72 times my 5. And 120 times 3 gives me 360. The 90 times the 4 gives me 360. The 72 times the 5 gives me 360. The only one that will be a little bit off will be your heptagon, and that depends on how you rounded. As you've finished off filling in the chart, we should have the very last row that we need to finalize at this point. You should have found that for any of your shapes, your triangles, quadrilaterals, pentagons, hexagons, heptagons, octagons, nonagons, and decagons, your sum of your exterior angles will always equal 360 degrees. So rather than having a complicated formula to find each exterior angle of a regular polygon, that means I could take my 360 and divide by the number of angles that I have. So the shortcut to find each exterior angle will be 360 divided by that number n. Please make sure this whole chart is filled out, both sides, before you turn it in for a grade.